is lesson 3 in the series pack, which is just a couple of tricky past exam questions that's worth going through. So this first one is talking about an art display, which is an arrangement of marbles. It says, when arranged in ascending order of mass, the mass of the first 10 marbles, the first marble, sorry, is 10 grams, and the mass of each subsequent marble is 3 grams more than the mass of the previous one, so that the R marble in the series has mass 7 plus 3 R grams. It wants us to show that the mean mass of the marbles is given by this. So you know how to calculate the mean. The mean of something, you add them all up and divide by how many there are. In this case, instead of X, I'm going to put in adding up R, where R is the mass. The mass, sorry, that's the mass of the marbles is given by 7 plus 3R. And if we just start looking at the top of this fraction, I can split this up into two sums. 7 times the sum of 1 plus 3 times the sum of R. You know the sum of 1 is just n, so that's 7n. Sum of R is half n plus 1. And all of this actually is divided by n. I can cancel this n off here now. So 7 plus 3 over 2 n plus 1. I'm going to expand this out. So 3 over 2 n plus 3 over 2 7. 3 over 2 plus 7 gives you 17 over 2, which you can factorize out the hand. Gives you the result they were asking. Then says in B, given there are 85 marbles in the display, use the standard summation formula to find the standard deviation of the mass of marbles in the display. Give me your answer to one decimal place. So we're looking for the standard deviation formula now. So you get the standard deviation formula on your formula sheet. The one that we're going to use is the one that is sigma equals root sigma x squared over n minus x minus squared. In our case, we're going to use x as the, I should use x rather than x is the mass of the marble. So let's just look at sigma x squared. The sigma x squared, we know the mass of the marbles is given by 7 plus 3R. So we can expand this out and use our standard results for series. So expand this out to 49 plus 42R plus 9R squared. And I can split this up into 3 sums. 49 times the sum of 1, plus 42 times the sum of R, plus 9 times the sum of R squared. Using the standard results, so 49 times sum of 1, that's just n, 49n, plus 42 times a half n plus 1. And then the last one, 9 times a 6, n plus 1. The result for this one is on the formula sheet. Okay. I can simplify the fractions, so this will simplify to just 21. Uh, 906 simplifies to 3/2, and then I'm going to write all these over a common denominator. So I'm going to write this as 98 over 2. I'm going to write this as 42 over 2, and I'm going to write, obviously, this is 3 over 2. That factorizing this then, so I'm going to take out the factor of a half, and I'm going to take out the factor of n. That's the only thing that these have in common. The first term has 98 left over. Second term has 42. Taken out the n, so I've just got n plus 1 left. And the last one has 3. I've taken out the n and I've got n plus 1. 2n plus 1 here. Right. Anyway, so 42n plus 42 Plus expanding this out, so we get 2n squared times 3, 6n squared. I'll get 2n plus 1n, so that's 3n times 3, 9n. 1 times 1. So 1 times that 3. Tidy this up. So we've got 6n squared. We've got 51n, and we have got 100. Yeah, we can pop all this into our formula. We know what n is at this stage. We know n is 85, so we could work this out. So if we evaluate this, n is 85. 6n squared is half. It's 85. 85. It's 51. This will be 2. At this stage, I'm also going to work out the mean. So we have x bar from earlier on is a half 3n. So 85 into there. Right, so we can put all our numbers in now to our standard deviation formula. So we've got this big number here. This is 2 divided by n. And minus our x bar, which is found in 8. And calculate that. Find 4. Then this next one, the first question starts off very nice. So just a standard summation formula question. So I split this up into 3 sums. 3 times the sum of r squared. 10 times the sum of r minus 25 times the sum of 1. And I can put my standard results in. So 3 times the 6. 2 plus 1. That's 17 times the half and n plus 1. And then minus 25 times the 1. I'm going to make all the fractions over 2, which works quite nicely. So this already cancels to a half for the first one, but 17 over 2 for this one, and the 25 we're going to write as 50 over 2. Then I can factorize out the half, I can factorize out the n that these have in common, and that's it. Everything else needs to go in this square bracket. So I've got n plus 1, 2, n plus 1 from the first term, I've got 17 and n plus 1 from the second term, and I've got minus 50 from the last term. Expanding out that square bracket using 2n squared plus 3n plus 1 minus 17n minus 17 minus 50. And 2n squared minus 14n minus 6. Factorize that 2 out as well from that bracket. And squared minus 7 and minus 30. Which is in the form that they asked us to show. And we write down what A and B are. So A is 7. and B is 33. In part B, then it asks us to explain why for k is a natural number, this is equal to minus k root 3. Notice we're going up from 1 up to 3k in here, and we've got tan of 60 r. Not sure what's happening to that off, so I'm going to work out the first few terms. So the first term I get from subbing 1 in. So 1 times tan 60. Then I sub 2 in. 2 times tan 120. Then I sub 3 in. 3 times tan 180. Let's do a few more. 4 times tan 240. 5 times tan 100. I might as well go to 6. So 6 times tan 6. And if I work out each of these, so tan 60 gives you these. Tan 60 gives you root 3. Root 3 for the first term. Tan 120 gives you minus root 3. Okay. Root 3 for the second term. Tan 180 we know is 0. Tan 240 gives you root 3, so plus 4 root 3. Tan 300 will give you minus root 3. And tan 360, 0. The pattern emerging here. So obviously we've got root 3 minus root 3, 0. Root 3 minus root 3, 0. Times them by a bigger number each time. But notice each of these groups of 3 adds up to minus root 3. The series goes up to 3k, so there'll be k lots of these groups of 3. Which gives you this minus k root 3 like that. But writing out the first few terms is a good technique for series if you're not sure what's happening. So using our results from part A and part B, determine any values of n, any value of n that satisfies this thing. Things to notice is first, this doesn't start at 1, it starts at 5. This doesn't start at 1, it starts at 6. And this looks like our answer to part B. So let's start with the left-hand side. The left-hand side, this is our answer from part A, but we're starting at 5. So this is we're gonna write this as the sum from 1 up to n minus the first 4 terms. So if we take our result from before, which was n squared minus 7 n minus 33, and then we substitute 4 into there. The left hand side, if we evaluate this point. Minus 1. Dividing that bracket gives you minus 180. We've got minus that, so plus 1. I'm going to leave that. Then the right hand side, 50 on the outside. And you've got the sum 5 is 6 up to 3. So again, in here we need to write the sum from 1 again minus the first 5 terms. And this, some first 5 terms, we've already written those out and had them before I deleted them. So the sum of the first 5 terms, remember, it was root 3 minus 2 root 3 equals 0 plus 4 root 3 minus 5. And if you work this out, you'll get minus 2 root 3. So it doesn't matter that it's not a multiple of 3 on the top. Just write out those first 5 terms. Don't try and substitute in like 5 over 3 or something weird into a formula. That's not going to work. This bit here is the result from part B, which is minus k or minus n root 3. In this case, we've got 3n on it. This needs squaring. So what we've got is 15 2 root 3 minus n root 3 squared. So we've got minus, which makes this one positive. I'm going to factorize out the root 3. So factorize out the root 3 and square it. Need to pull 3 out to the front. 45. And I've got 2 minus n squared. And I am going to leave that. We can put our two halves together now to form an equation. So the left hand side is got n squared minus 7n minus 33 plus 1 equals. On the right hand side, we've got 45 to n squared, which we're going to get a cubic equation here that we can solve. So we're going to expand everything out. So n cubed minus 7n squared minus 32 equals 44. Expand. So n 2 times 3 gives you 4 times 45 is 180. Minus 4n, so minus 180, and plus 45 is. That tells us on the left hand side, so there's 180 to cancel. So for n cubed minus 52n squared plus n equals 0. You can factorize out n. And then you can solve this in your calculator to see what you get. And you could have done a cubic, that would have been fine. Two solutions, 3 and 49. N equals 0, n equals 3. Plus 49. The final tricky bit about this is only one of these answers works. Because if you look at the sums here, we've got this one starts at r equals 5. Well, you can't have anything less than 5 on the top. So it must be the n can't be 3 or 0, it has to be 49.